designated to tell you, you should start recording now.
Yeah, that would be nice. Like in my little girls class, they all have roles every week that they play. There's like 20 jobs. Like they have the electrician, and his or her job is to turn on the lights off and on. They have the chair checker. They have the mini teacher who like gives out directions. That's one of the coveted spots. They have the veterinarian that feeds their turtle, but they just get to feed them like once a week. So
What course is
that's called kindergarten.
This plays a lot of things.
Uh-huh. But this week, the electrician is this little girl who's much shorter than all the other kids, and so she can't reach the light.
No, I was about to ask.
Right. So my girl is the assistant electrician, and she grabs Taylor and lifts her up so she can turn on the light.
Do they still take naps in kindergarten?
Yeah. I like 3 of the kids.
Can we go back? Now?
Yeah, y'all take naps anyway, so.
In between classes.
It's funny how you go from kindergarten taking naps, and then you get into high school and you don't take naps, and then you go to college and then you take naps all the time and you're not.
Yeah. Back before my wife started working.
I took naps.
This was the worst part about my wife starting working. Y'all care?
Sure.
She started back working full time a couple years ago, and the worst part is that I used to get to go home every day for lunch, and we'd have lunch together, and sometimes the kids would be there and stuff. And but then I always got to take a nap like right after lunch, just like 20 minutes, but it was just right just to come back. All right, so capacitors in series have the same charge. The equivalent capacitance is that funky 1 over C plus 1 over C. Q is equal to CV. And then fourth was the voltage equals V1 plus V2 plus ... That's for series. In parallel, we had capacitors in parallel have the same what? Have the same voltage, right? We'll see that for resistors too. The equivalent capacitance, C1 plus C2 plus ... Third was just Q equals CV. Right, so those are our rules. Let's tackle this circuit. Now with this circuit, the hard part is going to be what's in parallel and what's in series. So the first thing I want to do is just redraw this circuit as a more standard layout, like we've been doing when we draw our circuits, because this isn't really the way that we would normally draw it. So if you look at circuit diagrams, this is more like what you would see, where it's sort of laid out on this grid-like fashion. But it might be a little more difficult for you to interpret. And by the way, on your exam, you will have a capacitor circuit problem, and it'll be similar to this, slightly more difficult maybe, slightly easier maybe, but about this difficulty, give or take a little bit. All right, and I would ask you a question like, what is the equivalent capacitance, and then what is the charge, and what is the potential on every capacitor? If you go back to the old exams, there are questions like this basically on every exam for this material, and there are different circuits for you to practice, and we'll do several for you to practice. Well, let's first just redraw this circuit. Whenever you redraw a circuit, you won't always start off with this side of the battery and go in this direction. I guess you could do it the other way, but that's sort of the standard. Right, so I'm going to start with my battery, and I'm going to follow along until I come to the first branch, which is right here. All right, I have a split in the wire. And along the way, I have capacitor C1, so I'm going to draw it right here. This is C1, and it's 6 microfarads. And then I come along and I have a split. I'm going to draw that split like this. Okay, so this point right here, I'll call it point 1, is the same as this point. I have a split into 2 sections. And let's see, let's do the top part first. I'll go up in this direction. And then I have a capacitor. That is C2, and it's equal to 4 microfarads. What happens after C2 here? I have another split. So I'll call this point 2. So how do I draw that up here? What's going to happen to that wire at this point? Not down. It's going to split again. So see, I split into 2 pieces right here. So I'm going to split that wire into 2 pieces. And then I have 2 capacitors. I have C5 and C4. C5 is 2 microfarads, and C4 is also 2 microfarads. All right, let's stop there, and we'll come back to point 1 and go in this direction. Now C3, which is equal to 1 microfarad. After that capacitor, where does my wire go? The thing about electricity, in these circuits with the capacitors, we don't have current flowing per se in the same way that we would in a DC circuit, but we can think of electricity flowing through these wires. Oh. Nope. You can think of the electricity always wanting to get back to the battery, and it's going to take the easiest path that it can in order to get back to the battery. So where is it going to go right after C3? It's going to go straight back to the battery. I'm going to draw this in sort of a funky way, but watch. It's going to go straight back to the battery, just like that. The reason I drew it like that is because here, when I have these two capacitors, they come back together, right? And then it goes back to the battery as well. So these two capacitors hook up like that. Actually, let me redraw it just a little bit. They look like that. So this circuit now is the same, is identical to the circuit on the left. I know probably about half of you are saying, well, I don't really see that, right? But we're going to get some practice. We'll do a couple more, and then there's some in your homework as well. And that's really the best way, is just to get practice doing this. But now I just want to find the equivalent capacitance of this circuit, and then along the way I want to find the voltage and the charge on each capacitor. Which part am I going to look at first to find the equivalent capacitor? C5 and C4, because those two are, it's a pure parallel branch. There's nothing in series within it. It's only two capacitors in parallel. So I'm going to do C5 and C4. That's a 2 and a 2. I'm going to call that new capacitor C54. I'm going to redraw it down here. There's C1, which is 6. This is C3, which is equal to 1 microfarad. C2 is equal to 4. And now I'm going to call this C54, because it's the combination of C5 and C4. And it's equal to 4 microfarads. That's just 2 plus 2. Now which ones am I going to combine? Right, I have two capacitors in series right here. That's this one, and I combine those. Remember, if I have a 4 and 4 in series, what is that equivalent to? 2, right. Remember, I have those simple numbers that I like to use just to make your math easy, because I'm that kind of guy. And 1 over a half is equal to 2. Okay? And so if I redraw this, you don't have to redraw it every time, but I find that it's nice. You'll see why in just a bit when we're finding the voltages across each. Oh wait, no, I missed. Yeah, 4 and 4. So that's 2. I'm going to call this C254 because it's the combination of all three of those. And then C3. And now I'm going to combine C254 and 3. What's their equivalent going to be? C3 was equal to 1. What's that equivalent going to be? All right, 2 plus 1 is equal to 3 microfarads. And now I want to combine the 3 and the 6. And that'll give me my final equivalent capacitance. What's a 3 and a 6 give me? 2. 2. Right, 1 over 3 plus 1 over 6 equals 2. That's 1 over 3/6, which is equal to 2 microfarads. All right, let me write that. So 1 over 3 plus 1 over 6. That's 1 over 2/6 plus 1/6. That's 1 over 3/6, which is 1 over a half, which is equal to 2. All right, I think this was a 10-volt battery, is that right? Oh, it's 12, okay. So that was the end of that problem, but on the test, you'll have to find the charge and the voltage on each of them. So let's go through this one first. Once you begin to see this, it'll be fairly simple. First, I'm going to start with my simplest circuit, all right? What is the charge on this capacitor? Q is equal to 24. It's 24 microfarads. And I know further that that charge is on these two capacitors here. I know I have 24 microfarads here and here. So I could find the potential on either one of these, the voltage across either one of these, because now I know it's charge and it's, capacitance. I could do it another way, just by looking at the capacitors. Smaller capacitors carry a smaller or bigger potential. A bigger, because that inverse relationship, Q is equal to CV, recall? So if I have a small capacitance, that means I have a bigger voltage. And here, my capacitor is half this, so I know that my voltage is going to be twice what I have here. But they have to add up to equal to 12. So I know my voltage here has to be what? 8, and it has to be here 4. Right. We had a similar problem last time. So here I know, just from this sort of reasoning, not doing any math, that's 8 volts and that's 4 volts. But if you wanted to actually go through the step, you would say, I have 24 microfarads, and so the voltage across 2, 5, 4, 3 is going to equal, was it Q over C? Yeah, Q over C, which is 24 microcoulombs. I'm sorry, my units are wrong here. Microcoulombs divided by the capacitance, which is 3 microfarads, which is equal to 8 volts, which is what I have here. So there are lots of little internal checks you can do here. You can also see that the charge here, 8 times 3 is 24, and the charge here, 4 times 6 is what? It's also 24, which is what we had over here on the equivalent. Alright, so things will start falling into place now. I have 4 volts on C1, so that would be one of the answers. Let me make a little table here. I have 5 capacitors, and you'll see on the test that you'll have a table similar. This will be 1, 2, 3, 4, 5, and I want to know Q and V across each of those. So the voltage across the capacitor, the charge on the capacitor. And now we've already found one of these. What was that? Oh, C1 has 4 volts and 24 microcoulombs. Now, I can start filling in some other things because I know the voltage across this capacitor is what? It's 8 volts. Very good. If I have 8 volts across this capacitor, which is the equivalent for these 2 capacitors, that means that I have 8 volts here and 8 volts there. So 8 volts is for C3, so I'm going to put that in. Oh look, C3 had a capacitance of, what was it? 1, so its charge is, what? Was it, Linping? 8 microcoulombs. Alright, so it's kind of like in Sudoku, when you start getting those blocks filled in, then they all start coming a little more easily, right? When you get a bunch of Sudoku blocks filled in, like they all play Sudoku. Yeah. Alright, now, let's go back up here. So now I've gotten this one, and I've gotten this one. Now let's address this 254. I know if I have 8 volts there, what is my potential across this capacitor? Why is it 4 volts? I have 2 identical capacitors that are splitting that 8 volts because they're in series. So I have 4 volts here and 4 volts here. So let's go ahead and put that in. I have 4 volts for C2, which was 4 microfarads. And so that gives me what for the charge? Wasn't it 4 microfarads? No, 16 microcoulombs. Remember just saying Q is equal to CV. So anytime you get one of these quantities, the other is going to come just through Q equals CV. Okay, so now I still need 4 and 5. Almost done there because I know the potential across this is 4 volts. So what's the potential across C5? I have 4 volts. And the potential across C4 is also 4 volts. Alright, so I have 4 volts across those two. And so my charge then is what on each of these? Were they both 2 microfarad? Yeah, so I have 2 times 4 is 8 microcoulombs. 8 microcoulombs. I think it's better to draw it because then you can see the relationship, how all the capacitors, as you step backwards, you see we sort of stepped backwards, beginning with that equivalent capacitor and figuring out what was the charge on it, and then it sort of falls into place as you go back. I like to do easy numbers too, so that you should be able to look at them and not have to worry too much about calculations. But think about the relationships between the voltage and charge for capacitors, either in series or parallel. Down to the table? Yeah, it's Valentine's Day.
Oh yeah, that's right.
We don't celebrate Valentine's Day. Like, we don't even say Happy Valentine's Day to one another. Is that terrible? Our anniversary, we just had our anniversary just a few weeks ago, so that's like our big day.
Oh, I guess we said that you didn't even say anything.
11 years.
Congratulations.
It's been really nice. But my wife is exceptional, so that's hard. What, Limping? It's what in China? Light Festival. What is that? Oh, the end of the lunar year. Yeah. Okay. The beginning, right? What do you do on the Light Festival? You light candles and stuff? Electric lights? Yeah. Okay. Dumpling. We should have dumplings for the whole class. That'll be good. Yeah. Okay. Well, y'all are chatty this morning. Is this okay with this?
Yeah.
Yeah.
We just want to make the week even better.
I appreciate that. Okay. Why don't y'all try this? This is a simpler circuit, but what is the charge on the 3 microfarad capacitor? You could have little simple circuits like this in the multiple choice part. Largely, you should be able to look at this and be able to tell what it is. All right, just about 10 more seconds. Yeah, still missing a few people. 6, 10, 14. Stop at 2:45. Just a few more seconds. Are y'all missing clickers today? Some of you? No, we have 14 people here, but only 11. All right, let's see. B is the right answer. But you should be able to, you should be able to just look at this and tell me what the answer is. Let me show you why. Because first of all, you want to recognize that this has no bearing on the question, because that's an independent part of the circuit. It doesn't impact the charge on the 3 microfarad capacitor at all. So you could go through and find the equivalent capacitance, but it's not really going to help you at all. All right, so that doesn't really impact you. What we do know is that the potential across this branch is 12 volts, because that branch is in parallel with the other, and so it's like it's hooked up independently to the battery. And if I have 12 volts, then I know that that 12 volts has to be shared by these 2 capacitors. And as we had a question earlier, the voltage across the 3 microfarad has to be what? 8 volts, right. 8 volts, and so this has to be 4 volts. And 8 times 3 is equal to 24. Now, sort of the more laborious way to do this is I could say the 3 and the 6 has an equivalent of 2 microfarads on 12 volts. I can draw this other 2 microfarad as well. And the charge on this capacitor is Q equals CV, which is 2 microfarads times 12 volts, which is 24 microfarads. And then I say, well, these capacitors over here are in series, and so they have the same charge, because caps in series have the same charge. And so the answer then will be 24. But you want to be able to get to the place where you can just look at that circuit, something as simple as that, and say, well, yeah, this is 8 volts, this is 4 volts. The potential across the 2 microfarad is what? What's the potential across this capacitor? It's 12 volts. Okay, let's try another one. When my little boy was like 2, 2.5, he asked about Valentine's Day because he was like in this preschool thing, and I don't know, he asked about Valentine's Day. He wasn't in preschool, but we told him it's a day when people tell one another that they love one another, because that seemed like a simple explanation of Valentine's, as opposed to it's when they want you to go buy candy and flowers and all this business. And so he goes outside, and we had just moved to this house, and we had new neighbors. And our neighbor, or the lady that lived across the street, comes out the door, and we say, "Oh, hey, Kathy," and Micah says, "I love you." And she just sort of stopped. "Oh, okay, I love you too." It was very sweet. All right, what is the equivalent capacitance of this circuit? Again, hopefully something that you can do quickly in your mind. It's not working in your mind?
Oh, I already got it.
Oh, you got it.
I didn't want to go doing the other one.
All right, about 15 more seconds. I'll stop at 45. Some more we got there, aren't they? Where were y'all last time? All right, at 45, I'm stopping. Let's see, I think that's right. So first we start with these. 1 over 4 plus 1 over 4 is equal to 2. And then we combine that with this. That gives us 4. And so we get 2 4 microfarad capacitors that are in series with one another. And that's 1 over 4 plus 1 over 4, which is A. Now, what is the potential across the 2 microfarad capacitor? Everybody has this in front of them? I can scroll up if you like. you all have it. Here, I'll the potential across that 2 microfarad capacitor is at 8, 4, 6, or 2 volts. I'm going to draw out the equivalent circuit here. I'm going to leave the thing open, though this might help you a little bit if you're uncertain. I want to know the voltage across this one. Alright, so a few more seconds. I'll stop at 145. Still missing a couple people. Y'all clicked in? And is there a person missing a clicker today? Oh, there it is. Alright, C, is that right? Yes, that's right. Alright, so I have 12 volts here. That means I have 6 volts here and 6 volts here. That means I have 6 volts here, and that means I have 6 volts here and here. So 6 volts is the answer. Alright, what's the voltage across this capacitor? It's 3 volts, right. So I had 6 volts across these 2 capacitors. That was this, right here. So they split that evenly because they're identical capacitors. Alright, what do we got? Yeah, we have time. Let's do another problem. I'm going to leave y'all to do this on your own. I'm going to help you get started drawing it out, and then I'll leave you to do it. So first I just want to draw it out. I'm going to start here and go in this direction. There's my C1 equal to 3 microfarads. And then I come all the way up here and I have my first break, and it goes right there. So this point right here is the same as this point. I have a break in the circuit. And then I'll take the top branch. I have C2 and C4. C2 is equal to 3. C4 is equal to 6. Notice these are common pairings that I've been using. And then I have C3 on the bottom. It gets a little tricky here because, see, all these come back together to the same point right here. And then that's the beginning of a new parallel branch. Y'all just a minute to absorb that. That top square is a parallel branch all on its own. And where that square comes back together, when you have that wire joining those two pieces, that means that that parallel branch is now closed. And I've started a new parallel branch. Follow me on this? This can be kind of difficult to see right at first. But this is more common way to draw circuits, so it's useful to be able to see it just spatially. It's also just a useful exercise, spatial thinking. Alright, then I have a second parallel branch. Looks like this. I have a 2 and a 2 on the top, and a 2 on the bottom. That's C5, C6, C7 on the top. And C5 on the bottom, equal to 2. That circuit is the same, and that's probably the most difficult part. And that's where you're going to lose the most points, too, when you're doing it on the test, unfortunately.
Oh, thank you.
Thanks for letting us
Yeah, because if you get that wrong, the whole thing is going to be wrong. And, well, I give lots of partial credit, as you know. If you mess that up, it's going to be hard to eke out that partial credit. There'll also a hint on the test when you get to this. Like, even if you get this number wrong, you can still get half the credit by getting this number, at least the calculation, correct. Remember, Q is equal to CV. So even if you get V wrong, but you use the correct capacitance, then at least you'll get half, or, you know, half credit partially anyway. Right. So y'all continue on. I'll give you a few minutes head start.
Let's start.
You know, it's like one of those horror movies where the bad guy gives them like 5 minutes head start before he comes after them with a shotgun or whatever. Your first step will be to simplify each circuit down until you find the equivalent capacitance. the equivalent capacitance here? It's equal to 1, right? Once you get these circuits drawn, you want to start filling in your known quantities. So like there are some voltages that you can just state right off that you know. Like for example, the voltage across C1, C5, C3. All right. So what is the voltage across C1? It has to be 4 volts. Do this in red so you can see. The reason it has to be 4 volts is because I have 12 volts here. These are all identical capacitors. So I have 4 volts there and 4 volts there. What is the voltage across these two capacitors? They're in parallel. Caps in parallel have the same voltage.
So that's 4.
Right, so I have 4 volts. I'm going to start filling in numbers that I have here. So I know that V1 is 4 volts. Also now C5 is 4 volts. And C3 is also 4 volts because I know I have 4 volts here and 4 volts here. All right, and I have likewise 4 volts here. Now all we need is 2 and 4 and 6 and 7, and we'll be done. This is 1 microfarad. All right. What is the? Well, let's see. No, that's not that easy. What is the for 6 and 7? What is it? I have 2 and 2 for 6 and 7. So I have 2 volts and 2 volts. And then to find the charges, you just go back and like for C1, which was 3 microfarads, 3 times 4 is 12 microcoulombs. So I'm going to leave that for you on your own. Now, this is really probably the hardest part, is finding the voltage across these two capacitors. I know that they share 4 volts, but since 4 doesn't divide up evenly like we did for 12, where it was 8 and 4, like it's a fraction. What is it, Linting? What's the value? Do you know? And 4 over 3? Yeah, 8 over 3 and 4 over 3?
Yeah, I was just going to say divide the 4 by whatever number it is that you're looking for. And that works. And just do the fraction. So 3 divided by, 4 divided by 3, and then the next one.
4 divided by 6? No, that doesn't work. I don't know. The way I would do it, I would recommend that you just do it this way, that C24 we know is equal to 2 microcoulombs. Right, we've already found that. And so that was right here. And so the charge across those is going to be 2 microcoulombs times 4 volts. So I'm going to have, 2 microfarads, pardon me, is going to be 2 microfarads times 4 volts, so I have 8 microcoulombs. That means I have 8 microcoulombs here and 8 microcoulombs here. So I can go and fill in that on my chart for Q2 and 4, 8 microcoulombs and 8 microcoulombs. And then I can find my voltage, which is going to be voltage is Q over C. So as Lin Ping said, it's going to be 8 divided by 6, which would be 4 over 3 volts. And then this would be 8 divided by 3 volts. That just takes the charge divided by the capacitance, Q over C. And then that's the end. That's the answers. Go with me on this? Yeah, of course. Yeah, I prefer it in fraction.
I guess material only work for the first one.
Right, it just worked for the first one, yeah. So, not a true theory. All right, we're going to work through at least one more of these in class on Monday, and then there's one in the homework. But then in the old test, like I said, you can find one in practically every test. Usually it's exam 1 for this material. Yeah, Jose?
You said that for the test it's going to be the rest of chapter 2, 3, and 4?
I don't know if it's going to be chapter 4. I might have been rushing things a bit.
Okay.
Little 12.
So
I sort of
the
get.
rest of chapter 2 and then 3, we just said.
Yeah, chapter 3 is really short, though. So we might get a little bit into chapter 4, but not all of chapter 4, because chapter 4 is pretty long. Chapter 4 deals with DC circuits, so it's sort of like this, but with resistors. And then we have some other things where capacitors come back as well. All right. We have 3 minutes. We can sit around and shoot the ball, or y'all can go. I don't want to start a new problem.
You can start talking about your personal feelings.
Your personal feelings? Yeah.
That's always fun.
We could just sit around and tell one another that we love one another. 'Cause
I
it's
know
always
it's Valentine's Day.